All right, in this lesson, we are going to talk about how to simplify square roots in order to use the quadratic formula in our later lesson. So you have to know your perfect squares in order to be able to do this. And so if you don't know your perfect squares, you need to start memorizing these. Okay, and so when you have a perfect square, if you see the square root of 100, that would equal 10 because 10 squared is 100. A square root unsquares things. And so the square root of 9 would be equal to 3 because 3 squared equals 9. And so if you have a larger number, you can actually use a square root property and break these up into 9 times 100. And then if you take the square root of a product, you can split that product up into their own square roots. Okay, and so I can split this up into square root of 9 times square root of 100 to make it more manageable. And so that would be 3 times 10, which would be 30. Okay, and so that's the idea of simplifying square roots is we want to break up the radicand, the expression under the radical, into what a product that involves a perfect square. So for square root of 18, that's not a perfect square. Nothing squared would give you 18. That's an integer. And so what we can do is I can break this into 9 times 2 and then separate them. And then square root of 9 is 3, and square root of 2 is as simple as it gets. So when we say simplify square roots, that means the expression under the radical should no longer have any perfect square factors. 2 has no perfect square factors. In fact, it's prime. Okay, and so 80, when we're looking for perfect square factors of 80, you can look at this chart. And I start at where 80 is or close to 80 and look for perfect squares below that. That would be a factor of 80. And so 80 is 16 times 5, and 16 is a perfect square. And so we can split that into 16 times 5, which is square root of 16 times square root of 5, which would give us 4 square roots of 5. And so these are equivalent, except now our radicand no longer has any more perfect square factors. Okay, and so just like I had to hunt for a perfect square factor of 80, sometimes the numbers are even larger and it's very difficult to find perfect square factors. And so what you can do anytime is make a factor tree. And so 294, when you're making your factor tree, you can use any 2 factors. And so if it's an even number, I usually use 2 and then just keep cutting that number in half. So 294 cut in half would be 147. And then 147 is not even, but it is divisible by 3. You can know a number is divisible by 3 by adding up the digits. And if that number is divisible by 3, you know the entire expression is divisible by 3. And so 147 divided by 3 is 49. And 49 can break into 7 and 7. And so you're trying to get all the primes. Once you see all your primes, you're done with your factor tree. And then anytime you see a prime repeated, that means it was a perfect square factor. And so make your radical, and any factor that pairs up gets written outside the radical, and any number that doesn't pair up has to be written inside the radical. And if you have more than one number, like we do in this case, you just multiply them together. And so this would simplify to 7 square roots of 6 for our final answer. Okay, so for 648, make a factor tree. And so we can use 2 and 324, 2 and 162, 2 and 81. And here I'm already seeing a perfect square factor, but if you want to go all the way to the primes, it's just a good habit to make sure you're done. Okay, and so I have a pair of 3s. So a 3 gets written outside. And then I have another pair of 3s. So a second 3 is going to be written outside. And then I also have a pair of 2s. So 1, 2 is written outside. And then we have one lonely 2 left behind. So he has to stay in the radical. And so multiply these numbers together. 2 times 3 is 6 times 3 is 18. So the final answer is 18 square roots of 2. Okay, 54 I know is 9 times 6. So for the smaller numbers, if you just want to break them down without the tree, it's whatever's easier for you. You'll get the same answer either way. Okay, 32 is 16 times 2. And so 4 square roots of 2. Okay, 384, I think I'm going to need the factor tree. And so that's going to be 2 and 192. 2 and 96. 2 and 48. 2 and 24, 2 and 12, 2 and 6, 2 and 3. You don't have to use 2s. It's just 2 is an easy prime for me, and so I typically go with 2s until I can't anymore. All right, so we make our radical, and now we're going to pair them up. So I have a pair of 2s, so 1, 2 outside. I have another pair of 2s. So this was the first pair, second pair, and we're going to multiply them together. We have a third pair, and those are all the pairs. And the only thing left behind is a 2 and a 3, so both of those stay in the radical. So 2 times 2 is 4 times 2 is 8. Square roots of 6 would be our final answer. Okay, so this next one is negative, which requires us to know something about imaginary units. And so coming down here, the imaginary unit I is the square root of -1. We need that because you can't square root a negative number and it be something real. Nothing squared could have ever given you a negative number unless it's imaginary. And so in order to be able to take square roots of negatives, we need to rewrite this as a product of -1 times whatever number we're interested in. And then we can break it up just like we have been. And then the square root of -1 is just defined to be I, the imaginary unit I. We just made it up. Mathematicians defined it. And then square root of 64 is 8. And so the standard notation is to put the real number followed by the imaginary unit. And so you should write it in that order, just like as if I were a variable. Okay, and so here, square root of -9, we can do the same thing. break it up into square root of -1 times the 9, which would give us I3, which is the same thing as 3I. So you can start, whenever you see a negative, just take an I outside the radical, and then take the square root of that positive number, which is just 7. Okay, and so if you see a perfect square that's negative, you can kind of jump to it. And so square root of 121 is 11. Because it was negative, this would equal 11I. So if I had like square root of -25, that would be 5I. Okay, square root of -18, we know there's going to be an I. So take an I out, and now we can just focus on square root of 18. And so 18 is the same thing as 9 times 2. And so that means, I'll go ahead and rewrite it. We can also take a 3 outside the radical. Okay, and so standard notation is put the number, then the I, then the radical expression. 3I square roots of 2 is the standard notation for that. Okay, here we have a negative outside and we have a negative inside, so that means we're going to have a I outside with that negative. Those negatives don't cancel. Okay, and so now we can focus on the 96. I'm going to make a factor tree. 3 and 32, 2 and 16. Again, you can pick any two factors. Your primes at the end should match either way. And so sometimes when I see a pair, I stop. Okay, and so I have a pair of 4s. So 4 is going to be written outside. And then a 3 and a 2 are going to be written inside. And so that would be 4 square roots of 6, but we still have this negative I here. So we're going to have the negative, we're going to have the 4 and the I, and then the square root of 6 for our final answer. Okay, the 4 was outside, the negative I was outside. And so when you write them all outside, make sure you put the I after the number. And then the square root comes last. Okay, once again, take an I out, so I have negative I square root of 72. And then focusing on square root of 72, that's square root of 9 times 8. Or we can actually do better than that. I'm going to do the factor tree. So 9 and 8, 3 and 3, 2 and 4, 2 and 2. So my primes are 3, 3, 2, 2, 2. I have a pair of 3s, I have a pair of 2s, and I have a lonely 2 left behind. And so that means I would have a 3 outside, a 2 outside, and then 1 2 left behind. And so this simplifies to 6 square roots of 2. And so now going back, we have a negative I and a 6 outside the radical, so negative 6I, and then we have this 2 inside the radical. And so our final answer is negative 6I square roots of 2. Okay, and so like I mentioned earlier, our goal is to eventually use this when we simplify the quadratic formula. And so we're going to have some numbers outside the radical. And so here we have a 5 sitting outside the radical. You just kind of ignore it for now. And so noticing there's a negative, we're going to have a I with the 5. And then just focus on your square root of 32 like we've been doing. And so square root of 32 is the same thing as square root of 16 times 2, which is 4 square roots of 2. And so that means I'm going to have a 4 outside the radical as well, with the 5i. And then the only thing left under the radical is a 2. And so this simplifies to 20i square roots of 2. Okay, for 19, we're dividing this whole thing by 3, but be very careful. This radicand of 63 cannot interact with this 3. Okay, numbers under the radical cannot interact with numbers outside the radical. And so just ignore the square root of 3 for now, and just, not the square root, but the 3 on bottom, and just focus on your, we know there's going to be an I, just focus on square root of 63. Okay, and so 63 is 9 times 7. 7 is prime. Square root of 9 times square root of 7 is just 3 square roots of 7. Okay, and so coming back to this expression, I can replace square root of 63 with 3 square roots of 7, and we have this I, and then we are bringing back this division by 3. Okay, now, if you have a number outside the radical and outside the radical, those can interact. And so 3 divided by 3 is just 1. And so they cancel out and leave us with just I square root of 7. And that's how you would write your final answer. Okay, this is an expression, the 20 and 21 are expressions you will get from using the quadratic formula. So this one's an important example. Okay, and so ignore everything outside the radical for right now. We're going to focus on square root of 76. I'm going to make a factor tree. So 2 times 38, 2 times 19. 19 is prime. We have a pair of 2's, and so 2 square roots of 19. Okay, so coming back to this expression, I have a negative 6 plus or minus, and I have that 2 on bottom. But now I know square root of 76 is equal to 2 square roots of 19. Okay, so just replacing that. Now, if you have numbers outside the radical, they can interact. So I've got a negative 6, I've got a 2, and a 2. Both of those are divisible by 2. And so negative 6 divided by 2 is negative 3. And then 2 over 2 is just 1. So we don't usually write the 1. It's not wrong if you do, it's just not simplified. And so typically you'll just see it as negative 3 plus or minus square root of 19 as the final answer. Okay, last one. We know we're going to take an I out, so we're going to have 8 plus or minus I square root of 8 over 4. And then we just focus on the square root of 8 right now. Okay, so square root of 8 is the same thing as square root of 4 times 2. Break them up, that gives us 2 root 2. Okay, so I'm going to copy this down, 8 plus or minus, and I still have that I, but now I have a 2 root 2 all over 4. Okay, and so treat this like a variable. It can't interact with anybody, but we can simplify 8, 2, and 4. So if there's a GCF between all 3 of these numbers I just highlighted, you're going to divide each of those by that GCF. All of these are divisible by 2. Not all are divisible by 4. 2 is the GCF. And so 8 divided by 2 is 4. 2 divided by 2 is 1, so we're not going to write it. And then 4 divided by 2 is just 2. Okay, and so that's the best way to leave your final answer, is just take out any GCF as long as it's in all 3 places.